Good morning.
Good morning, sir.
Good morning, sir.
Good morning, sir.
Good morning, sir.
Good morning. This is visible in the screen.
Yes, sir.
Okay, so last class we have started dynamic analysis part. We discussed the principle given by D'Alembert, and we discussed dynamical equivalent link. Then we said that the dynamic force analysis or dynamic analysis of a mechanism can be done. The graphical method can be done. There are two ways, considering combined action of all the forces simultaneously and considering the effect of each force separately, then combine their effects. Okay, that is called superposition method. So today we will discuss these two methods. So first we will discuss this method. Okay, this is our lecture number. This is dynamic analysis. We are discussing first we will discuss this graphical method. Then we will discuss the analytical method, because the analytical method it is not easier in pen paper to use the analytical method when you have a computational system. That time this analytical method is much more useful, and in today's scenario that is the way people do the analysis. So today's lecture is lecture number 16. So your midsem starts, which date your midsem starting? I think on 4th your midsem is started.
Yes, sir.
So we will have today's class. So including today's class, we have 5 classes. 1st March is a holiday. Okay, 5 classes. So I'll try to finish this dynamic force analysis and we'll discuss some part of flywheel. Okay. So the method we are going to discuss today is combine effect of all the forces. We write all the forces. When we write all the forces includes all the moments, because you know for a 4-bar mechanism, if there is a moment acting on a link, we can always represent that moment into a force, right? That we have discussed in our last class. So let us, and this we will do for a 4-hour mechanism. Okay, let us take one example. And we will solve this. Okay. Suppose this is the crank, which is connected to this coupling rod. Okay, and that is connected to the 4th link. Okay, so this is link 2, 3, 4. We have these points O2, O4. Okay, and this is subjected to forces and moments. This is subjected to forces and moments which arbitrarily we show this. Suppose this is the general force which is acting on link 2. We will call it R2 is a vector, and there is another force acting on link 3. Let's say this is R3. A force is acting on link 4, which is R4. Remember that this R2, R3, R4, there represents the externally applied forces, moments, and the inertia forces and moments. Okay, everything we are representing here as R2. For this link, it is R3. For this link, it is R4. But in this case, there is something which is unknown and we want to determine that. Okay. So this force analysis, why we are doing this force analysis? Some unknown we want to find out. Suppose for this case, the unknown is the uh, externally applied torque M2 here. This is the unknown. Okay, and we want to determine what is this. In the meantime, we also will determine what are the joint forces acting here. All the four joints, what are the joint forces acting here? Understand the problem. Again, I'm saying that all the external forces, there could be many forces which are acting on this link. There could be other moments or torques which are acting on this link, and there are inertia forces and inertia torques due to this inertia of this link. All of them are clubbed together, and that is presented here by this general force R2. Similarly, the same quantities are represented here for link 3 by R3 and for link 4 by R4. Okay, now we will find out here what is this M2 required to run this mechanism. Okay, in the meantime, we will find out what are the joint forces. The process, the method we are uh, following for this is this combined effect of all the forces. What we need to do, we need to draw the free body diagrams again. Uh, so when you solve a problem in dynamics, if it is related to, if you are solving the problem using Newtonian method, then it is obvious that you must draw the free body diagrams. Okay, free body diagrams are must. So you must draw free body diagrams. So what we will start with in this analysis, we'll first draw free body diagram of link 3. Let's do that. So I first draw the free body diagram of link 3. So we draw this is link 3, okay, 2 endpoints, and this link 3 is subjected to this force R, not exactly. This is R3, okay, and now to complete this free body diagram, we need to show what are the forces acting at these joints. Okay, so suppose the force which is inserted by link 2 on link 3, and that force is, let's say, this force. We don't know the direction, we don't know the magnitude. Well, let us assume that the force is this one, and that force is P, and we will call it P. We'll call it P23. Okay. So this is the force exerted by link 2 on link 3. Okay. That is why we are writing P23. Similarly, there is some force which is which is inserted by this link 4 on link 3, and that force, suppose that force is this one, P, this is 4 3. Okay, so this completes the free body diagram of this link 3. Now what we will do, now we will dissolve this link 4 3 into this P4 3, we will dissolve P4 3 into its components along link 3 and tangential to it, to link 3. L3, just I'm writing L3 for link 3. So if you do that, suppose there is a component along this direction, and similarly we'll have a component along this direction. Okay, so those components you will get by dissolving this P4 3 along these two directions, and let us call this force along the direction L3. I'm calling L3 along the length, and this force is P43 T3 tangential to link 3. Okay, now let us draw the free body diagram of link 4. So let us draw free body diagram of link 4. So when you draw free body diagram of link 4, suppose this is our link 4, okay, which is subjected to some force here at the joint, which we will call P14, force exerted by link 1 on link 4. And now we will have another force which is exerted by this is the force exerted by
Link.
So we'll call this a P exerted by link 3 on link 4. Okay, so obviously this P43 or P34 must be equals to minus P43, right? For equilibrium of this point, this force must be equal and opposite to this force. Okay, again we will dissolve this P34 into two perpendicular orthogonal directions. One of the force is this one. We will call this force P34 along the length L4, and we'll have another component, this one, which is P34 tangential to link 4. This is our link 4. Okay, you can, how to get this component, just draw the first you draw a line which is perpendicular to L4, and then draw this line again. This line is perpendicular to this line, so you'll get this component. Okay, for drawing. Okay, so at the when you are drawing this, we actually don't know what is this P43. What is the direction? We don't know. Okay, then how will you draw? This is for just demonstration we are doing so, but before we draw this, we have to do some calculation to find out this joint force. From these two free body diagrams, we can get the joint forces. Okay. One thing we have not written here to complete this free body diagram, that is this force which is external to this link. We must draw that force. Okay, so that force is acting here, and it is suppose in this direction. This force is R4. Okay, so these are the forces which are acting on link 4 and link 3. Now let us apply these equilibrium equations for link 3. Okay, so can we call this point A and this point is B? So if you take moment of all the forces, about point A, this point is A and this point is B. If you take moment of all the forces about A, that must be equals to 0. Okay, that is the condition for equilibrium. So when we do that, we must take moment of all the forces. Let us take moment of this force R. To do that, we need the perpendicular distance from this line of action of R to this point, and suppose that distance is, let's say this distance is E3 or ER3. Just a symbol, this distance ER3. Then and if we take moments, all the moments anti-clockwise positive, then this is creating a moment clockwise direction. So we'll say that minus ER3 into R3. This is a moment created by this force. And then, are you guys there in the class listening to me?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
So then class, so we have to take moment of these two components. You see the distance, longitudinal component, the distance is 0. Tangential component, the distance is the link length. So suppose the link length is L3. So that means, and that component of force creating a moment anti-clockwise direction. So L3 multiplied with P43 is a tangential component, and that must be equals to 0 because there is no other force, okay, acting on it. So from here we can calculate P43, the tangential component is equals to ER3 by L3 into R3. Have I written it correctly?
Yes, sir.
So we have here this component known to us. This component is known to us. Component known to us means we only know the magnitude of the force. We still don't know what is the direction of the force. Okay. Now let us consider this one. Okay. Here we have this point is B. This point is O4. Now for this case, let's do it this way. Let's take again here for this case. Let's use the equation of equilibrium. So moment equation. Let's take MO4 summation of all the moments about 0.04 equals to 0. When you do that, so you have you need this distance from the perpendicular distance from this point. Okay, so this distance, let's say this is ER4. Okay, so and again for this case, according to the drawing, we can see that that is creating a moment which is clockwise. We will write ER4 negative. Okay, and then we have this force which is this force is at a distance L4. The link length is length of the link is L4. So this distance is L4. So we have again minus P 34 T4 is equals, sorry, that must be multiplied with L4 is equals to 0. So from here we get that this P34 tangential component is equals to ER4 by L4 into R4. Is it fine?
Yes, sir.
Now
Yes,
suppose
sir.
I
With
draw,
negative direction.
So minus sign.
there will be a minus sign, right? There will be a minus sign. Okay, so now suppose I draw a component of the same force, this force in this direction. Can I write down this force? So actual force is P34. Here we have written P34 equals to P43. Okay, so can I write this component of force, this red direction I have shown? We can write down this is minus P34 tangential to 4, right? I can write like this component of force. Yes.
Yes, sir.
So
Yes,
this
sir.
same, yeah, the same force, can I call this as P43 tangential to 4? Please understand this.
Yes, sir.
Okay. So when a force, this is a force which is inserted by the fourth link on third link, and this is a force which is inserted by third link on fourth link. Okay, they will be equal and opposite if you just take the same direction, right?
Yes, sir.
So from
Yes, sir.
that analogy, we will call this force, if I call it 4 3 tangential to 4, that must be equals to ER4 by L4 into R4, right? One only negative sign should not be there. Okay?
Yes, sir.
Okay? So after doing this, what actually have with us, you see that this P43 is a force. So two components of P43 are now are now known to us. What are these two components which are known to us? At least their magnitude, also direction. So one is this P43 here, from here you see P43 tangential to link 3. P43 tangential to link 3. This force is known to us. Here we were saying that this force is not known to us, but this is actually known to us. Why? Because you know this magnitude, and this force is tangential to link 3. So the direction of link 3 is known to us. Its tangential direction is this. That means this force is completely known to us. Okay. Another thing, we from this free body diagram, we have got this relation. From this relation, we see that the magnitude of P43 tangential to link 4, that is also known to us. P43 tangential to 4. These two components of P43 are known to us. Can we find out? Here the question is, can we find out P43 from these two components? That is a question now we will solve. So suppose here at this point we have some additional discussion. That is, suppose there is a force. Suppose there is a force F. F is a force is given. This is given. And two directions. This is, let's say this is one direction. And we have another direction. Two directions are given. Suppose this direction is A cap, this direction is P cap. Two directions. This is one direction and this is another direction. So can you find out what are the components of force F along A and B? How to find out this?
Sir, dot product.
Yes, you will do the dot product. F dot A will give you component of force along A direction, right? And if you do F dot B, you'll have component of force along B direction. But suppose we are doing graphically, what we do to get this forces component along A direction? कैसे मिलेगा?
Magnitude of F into cos theta, theta between F
No,
and
no,
A.
it's very simple. Suppose there is a force which is drawn on a paper, okay? And this length represents the magnitude of the force. This direction represents the direction of the force. We want to find out this force's component along this direction. How to find out? Graphically.
We'll draw
We'll draw
perpendicular.
Yeah,
perpendicular to it.
we will draw perpendicular line like this, right? Anna? So that will give us the component of the same force along A direction. Okay. So let us call it FA. FA. And this is FB. So how to get FB? You will draw another perpendicular. And this is FB. right? Okay, is it fine?
Yes,
This
sir.
is the way we get the component of
Yes, sir.
force. Now let us think about the reverse problem. Suppose you have component of the same force Fa is known to you, Fa is known to you, and component of same force along another direction, Fb is known to you. Now say Fa and Fb known, which are the components of same force F. Question is, can we find F? Can we find F? Can we find F?
Yes, sir. By drawing
Yes.
perpendicular lines and getting the intersection of these lines.
Yeah. So what we need to do, we need to draw perpendicular lines from heads of each vectors, right? So you will draw. So this is a problem which is, let's draw it again. Okay, suppose this is it. Then what you will do, you will draw another perpendicular line. This is the intersection point, and you will say, well, this is the vector you are searching for, right? This is F. Got it? Hello?
Yes, sir.
Yes, sir.
So now the question is, you see this joint force P43, its two components, P43 tangential to link 3, P43 tangential to link 4 are known to us. And from that, we want to find out what is P43. So let's now we are convinced that if these two components of a force is known to us, we can find out the force. Okay. So first we will draw, say this is P43. Let us draw it because the magnitude is known to us and the direction it is perpendicular to link 4. That means this force is known to us. Let us first draw this. Okay. I am drawing here this force. So this is P43 tangential to link 4. One component of the force P43 here. Another component of the force is P43 tangential to link 3. That is known to us, right? So let us draw that. This is P43 tangential to link 3. These two forces are completely known to us. From that knowledge, what we will do now, we will draw lines which are perpendicular to these forces, and those two lines intersect at a point. That point, when you join with this, that gives you the vector P43. So the joint force P43 is now known to us. Okay, convinced? Hello.
Yes, sir.
Yes, sir.
So now what we need to do for, let's say if we consider link 3, consider, consider link 4. When you consider link 4, the equation P14 plus R4 plus P, uh, what was that? P34 must be equals to 0, right? Just see from here, P14 is the force acting here. R4 is another force which is acting on this link. And this is P34 is the third force which is acting on this link. So these are the only three forces which are acting on this link. Then we can write down this, right?
Yes, sir.
Yes, sir.
Yes. So now let us draw all these forces. P14 actually not known to us. This R4 is known to us because that is given. This is R4. So let us first draw that R4. R4 is known to us. This is R4. And when you get this, actually you get P43. P43 and P34. Okay, P43 and P34, they are opposite, right? So from here you can draw the, from here you can draw that force. So this is all graphical. When you have this diagram, from this diagram you have the magnitude, length is magnitude, and direction is also known to you. So you can draw the same thing here, but now here you have the direction is opposite because we are P34 and P43 are equal and opposite. Okay, now this is R4. So obviously this diagram is completed with this vector, which you can draw using your scale. Your, so this, what is this vector? Red one, P14, right?
Yes, sir.
Is it fine? So this, now this P14, this red one, you measure this and multiply with the scale. So the scaling factor, whatever you have used here, so that gives you the magnitude of the force and direction of this force, joint force P14. Now we consider link 3. Consider link 3 again. When you consider link 3, what are the forces which are acting on link 3? Is P23, R3, and P43. So we can write down the vector equation P23 plus R3 plus P43. Okay, they must be equals to 0. Now you see here this P43 is known to you. R3 is also known to you. So let us first try drawing this vector diagram. R3 may be like this. That is known to us. R3. From this diagram, we know what is P43. So we draw that P43. This one is P43. That means we have this completing vector is P23. Okay, so from here, you see from here we got this P23. So P23 is now determined. Here P14 determined. Joint forces P23 and P14 are now known to us. The next step is to draw the free body diagram of link 2. So the link 2 looks like this. This is link 2. Let us draw the free body diagram of link 2. This is link 2 and it is subjected to some force acting here, which is P, what we will call
1, 2.
P12, right? And there is a force. Once we obtain this, the equal and opposite force will be acting here, right? Which is P32, right? 2, 3 is known to us. So P32 is also known to us. And this link 2 is subjected to this force R2 and this moment M2. R2 and M2. So let us use that. So suppose this is R2 and it is subjected to a external torque M2. Okay. Now it's very simple. We will now write down this equation to know what is this distance. Okay, suppose this is E, some distance, let's say this is E2, and we need to know what is this distance. Suppose this is ER2. So we can say here that P32 into E2 minus ER2 into R2 okay plus M2, this is equals to 0. So from here clearly you can see that ER2 into R2 minus E2 into P32, that gives you the moment M2. Okay. Also, from here you can also write down this equation. There must be equals to 0. P32 is known to you. That is this vector. R2 is known to you. That is this vector. R2. This is P32. These two vectors are known. That means obviously we'll have this vector is P12. So from here you can find out what is this joint force P12. This way you can find out all the forces and this required moment. Okay. If it is a question, then you can find out that, right? Do you understand this
Yes,
process?
sir.
This whole thing is a graphical method. Okay. So a particular problem will be given to you. From that problem, you have to first, what is your first thing in your problem? These forces and their direction will not be given. In your problem, it will be given, suppose some force is acting on this link, and what is the length of the link, what is the weight of the link, mass of the link, that will be given. From that you need to first find out, see, this is first this is a the for this problem we need to do the kinematic analysis, because To find out what is the inertia force and inertia moment, you need to know what is the rectilinear acceleration and angular acceleration. Okay, so first we need to find out these acceleration, rectilinear and angular accelerations. Once you find out that, you know, multiplying them with the mass and moment of inertia, you'll get the inertia moments and inertia force. Once you get the inertia moment and inertia force, then you have to write those force and moment into some in terms of force. Then you can define this. Finally, you can define this R2. Okay. Similarly, you have to define R3 and R4. Once you have these forces, then you will do this analysis. So when you do this analysis, what you will do, okay, you will draw these directions, all right, and no need to go for this proof. You just draw. Once you have the free body diagram of link 3 and link 4, obviously you will get these values. First you get the values P43 and P34, the tangential component with respect to link 3, tangential component with respect to link 4. Once you have these two and you have this direction and this direction, then you draw this diagram. Okay, once you draw this diagram, you will get this vector. So that is the point, that is the drawing from which you get this vector, the magnitude and direction of this vector. Once you have this, then you draw these steps and get all the other values. Got it?
Yes, sir.
So if you go to the website, my web page, the problem sets are given, I believe. From there, you can find out some problem and try to solve it graphically. Okay. The next method of this graphical analysis is superposition method. Okay. You have any question related to this method? Hmm? Do you have any question related to this method? If not, let me go to the next method, that is called superposition method. This kind of graphical problems will be there in the exam. To make it means, I have seen the question papers, answer books of online exam. 99% students, they copy from each other. Who is the source, who is or who is copying? It is really difficult to understand. So we believe that everyone copy. What we will do, I will give you a value and then I'll change the value with your roll number. Okay, just last two digits of your roll number. Suppose I give an angle here for this problem, an angle here, and I will add some number which is related to your roll number. Obviously, angles will be different for all the students. So your diagrams will be different. That means you need to practice. Okay. Only copying will not work. You will get 0 marks if you do not incorporate all those things. Let me discuss this superposition method. In this superposition method, we uh, separately we will consider the effect of forces, consider the effect of forces and finally combine all the effects. So what we will do, same, suppose we take the same problem. Uh, Suppose we take the same problem, this problem. We take the same problem. Now we will solve this problem in 3 steps. Step 1 is we will, so we'll have this mechanism, draw this mechanism, but here we will just consider, this is step 1. In step 1, we will just consider this R4, and we will call this torque required here is M2 dash. You can do it. You have to draw the free body diagram of this link and find out what are the joint forces, then consider this link, find out the joint forces, then consider this link, draw the free body diagram and find out this M2. That is the first step. Second step, what we will do in the second step, we'll take the same diagram, and now what we will do, we will consider only R3. We will not consider R4. We will consider only R3. And we will say that for R3, you need a torque here that is M2 double dash. Okay. All right. The same thing you will do, draw the free body diagram of these, get the joint forces, then free body diagram of this, get the joint forces, free body diagram of this, get the joint forces, and from there you can find out what is this M2. We will discuss this in our next class. Today we'll have not that much time, so I'm just giving you the method. Okay. In the third step, what we will do, we will take again the same diagram, and from this diagram we will, here at this point of time, we'll just consider R2 only. All other forces are not there. And we will say for this R2, you need a torque that is M2 and this 3 dash. Okay. So finally, when we solve all these problems, and then finally we'll say that what is M2 actually? M2 is summation of all these torques which we found in our different steps. This is nothing. This is the superposition principle. Okay. What about the joint forces? For the joint forces, suppose from here you get the joint force here P431. Okay. And from here you will get P43, maybe this way, double dash. From this analysis, you will get P43 this. So finally, what is P43? P43 is also equals to P431, P432, and P433. Okay. So same thing is true for all other joint forces. So in general, we can write down Pij is equals to Pij1, Pij2, Pij3. ठीक है? Have you understood this method?
Yes, sir.
So let's start doing this. Let's do the first step. I take this picture. And we will now draw it here. So first we will draw the free body diagram. You have to draw the free body diagrams, and we'll start with free body diagram of link 4. Okay. So, okay, let's first draw the free body diagram of link 3. When you draw free body diagram of link 3 must be, there must be a force which is acting here, which we will call P. P, P23, okay, 1. And there is some force which will be acting here, that is P 431, right? Now the vector equation must satisfy 2, 3, 1 plus P 431 must be equals to 0. From here you can see one thing, this must be equal and opposite. Another, the magnitude is equal and opposite. What about direction? Hello? What about direction of these forces? Are you guys there in the class?
Yes, sir.
180 degree,
Yes, sir.
What
Yes, sir.
about their direction?
180 degree to each other.
Yeah, that means what? Yes, you are correct. 180 degree to each other.
Opposite
What
to
is
each other.
this? Would be
Opposite.
this would be collinear. And you see one thing, these links are not supported by any moment at the joints, because joints are pin joints. They don't support, pin joints don't support moments, right? So there is no external moment. That means these forces are along the length of the link. Do you convince with this or not? These forces cannot be like this. The blue color forces which we have drawn first, the forces cannot be like this, because you see, if the forces are like this, they will create some moment, right?
Yes, sir.
Yes, sir.
But there
Yes, sir.
is no external moment to balance them. Here for this case, only joint forces are acting. There is no external moment to balance them. That means they must be acting along the length of the link. So from there, at least from this diagram, we have this, that the forces are along the length of the link. Now when you draw the free body diagram of link 4, then what you get, this is the link 4. It is under the action of this force R4, and there is a force exerted by this link 3, which is called P341, which is along this direction, because P341 is just the opposite of P431. Okay, so from here we have that, and it is subjected to some joint force, that is P14, okay, 1. So now you can apply the equilibrium equation and get the value of R4. R4 is known to you. So you can get the value of P334, right?
Yes, sir.
If this distance is, let's say, D4, then you can write down P341 into D4 minus, if this distance is, say, ER4, then ER4 into R4, that must be equals to 0, right? So that gives us this value, ER4 by D4 into R4. Fine?
Yes, sir.
Okay, so we stop here, and tomorrow we will continue this second and third step. We will take some example and we'll finish this discussion. Okay. If you have any doubt, list the doubt. Today I will not answer. Tomorrow we'll do that. Okay. Thank you for your
Okay,
attention.
sir.
Thank you, sir.
Thank you, sir.